upon recent request, and I mean I literally just read this comment on TikTok, we are talking about the elimination of alcohols. Also, before I get into the content, please make sure to leave a like, comment, save, and or subscribe to my channel if you like my content. Love y'all. Let's get into the content. All right, consider this compound. We have an alcohol group. Ooh. We know it's going to be eliminated, so removed. And we're reacting it with H2SO4 and heat. H2SO4 is an acid, and heat essentially means that there is time. You got energy in the system. Things can rearrange to more stable forms. We have to keep this in mind as we go through the mechanism. First things first, let's write out the actual structure of H2SO4. What it looks like is there is a sulfur double bonded to an oxygen up and down, and then an OH on each side. So the alcohol on our compound has two lone pairs. These lone pairs can act and go two in and grab one of those hydrogens on H2SO4. Two up. Why? Well, if we look at the conjugate base, the O minus is resonance stabilized. So this is a really good leaving group. Two in, two up. You can delocalize that negative charge. Hence, this hydrogen is very, very, very acidic. Therefore, it can be attacked by things like OH groups on our structure. Okay, so first step is the OH is going to protonate itself. So now the oxygen is attached to two hydrogens and it has a positive charge. It still has the one lone pair that it did not use, but since it used one lone pair to attack the white hydrogen, a part of H2SO4, it technically gave one of those pink electrons to the hydrogen. So you can think it lost an electron, now it is cationic. Whenever you have OH2+, this is a phenomenal leaving group. So it's literally going to say, peace out, goodbye. So the two electrons in this carbon-oxygen bond are going to go two up onto that oxygen, and it's going to leave as water. This is a phenomenal leaving group. So what are you going to get? We're going to get water, so OH2 neutral, and you're going to get a carbocation on the carbon that it left from. So this carbon is going to be cationic. So the carbon is attached to two other alkyl groups. 2' is not as stable as, for example, 3'. So we have to ask, could a hydride shift occur or a methyl shift? Because 3' is best. Therefore, if we can actually achieve a 3' carbocation, that would be the most stable and the most desirable. So to the left of our 2' carbocation, we can see that we have a 3' carbon. Therefore, this hydrogen can take its two electrons in the HC bond and go two over. And the hydrogen is going to jump from the pink carbon to the blue carbon. Therefore, the pink carbon is going to now become cationic. But we see that that is way better than the blue carbon being cationic because it is 3'. So now we have a 3' carbocation. This is way better, way more stable because there's 3 alkyl groups that can donate electrons to this carbon, acting as electron gun throwers, stabilizing that positive charge. So what happens next in the final step is a hydrogen is going to be stolen because this is still an elimination reaction. So a hydrogen can be stolen from a carbon that is 1 carbon away from this cationic carbon. Who is it going to be stolen from? Well, a base. Our base is going to be the water that was previously eliminated. So the water is going to take one of its lone pairs and go two in. Grab a hydrogen on a beta carbon. This would be our beta carbon, so a beta hydrogen. 2 over, and we don't need a 2 out because the leaving group already left in a previous step. And then we get the formation of a double bond, and we have our final product. that is all on the elimination of alcohols. We've also covered hydride shifts, where we had a 2' carbocation change to a 3' carbocation. Then finally, in our last step, this is where the elimination occurred, where the water came back in, grabbed a hydrogen, and we got our pi bond in the end. All right, this was a quick little video just for one of my TikTok followers that requested this, as they have an upcoming exam. So let me know if you have any questions, comments, or concerns. Have a good night. Bye.